Okay, kia ora. My name is Russell Keith-Magee. As Tom said, I'd like to thank the organisers for the invitation to speak today. Before I start, I would like to acknowledge that I am from Wajik Noongar Boodja, otherwise known as Perth, Western Australia, Kaya. It is a great honour to stand here on this sacred land today and acknowledge the Tangata Whenua of Wellington, Te Aotearoa, Ngāti Toa Rangatira, Ngāti Rakawa, and others who were here long before us and their ancestors who have passed on. Nō reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you. So, who am I? Why am I here? Well, for those who haven't met me before, the road that brings me here is long and twisty. Not twisted though, in joke. I have been part of the wider Python open source community for almost 20 years. I've been a Python user for probably 5 years longer than that. So while I was doing my PhD, 25 years or so, give or take. But I really started getting serious about Python about 20 years ago. It was the mid-2000s. I had this idea for a website that I wanted to build, and I was in search of a web framework to use. Now, despite having a PhD in computer science, I could not make head nor tails of the documentation for PHP. The convention over configuration of Rails just didn't quite sit right with me. So after trying a bunch of other Python web frameworks, because at the time there were plenty to choose from, I chose Django. Django was open sourced in June of 2005. I would have downloaded it somewhere around October of 2005 through a combination of abnormally good documentation at the time and background readability of Python as a language, and the fact that it was, at the time, a relatively new project with lots of notable feature gaps. I made my first code contribution in December of 2005, and by January of 2006, I was invited to join the core team. Django was a very big part of my life for the next 10 years. I was a major code contributor. I either wrote or I was a significant author of Django's test framework, multiple database support, aggregations, the validation framework, and countless other features along the way. Outside of the code, I served as the president of the Django Software Foundation from 2010 to 2015, during which time I oversaw the development of Django's trademark policy, the start of the Django Fellowship Program, and the grant for the very first Django Girls event at EuroPython 2014 in Berlin. All this work was being done either in my spare time or under the radar of my employer. My employer was aware of my involvement with Django. In fact, one of the reasons that I ended up getting so involved was a convenient coincidence. My employer was bidding on a contract to build an app, and I pitched the idea that making it a web app would make developing the app really easy, and it did. That web app became a major product line for the company. But I was never officially given 20% time or anything like that to work on Django. But if I answered a few mailing list threads or fixed some bugs or merged some tickets while I was on the clock, then okay, that was fine, that was tolerated. My work on Django did give me career opportunities though. In 2008, I was headhunted by a Brisbane-based company that was at various times called Plugger, What News, and We Are Hunted, until it was eventually acquired by Twitter and rebranded as Twitter Music. Very short-lived, but it was Twitter Music for a bit. That gig gave me lots more Django experience, but in addition to working with Django, I got my first exposure to native app programming. In 2010, We Are Hunted developed MySpace's first iPad app, MySpace Music Romeo. I left Hunted just before the Twitter acquisition to try my hand at my own startup. Along with my first boss out of university, I co-founded TradesCloud, and I was the sole technical employee of that company until we wrapped the business in 2015. TradesCloud was, first and foremost, a Django-based software as a service website that sold to tradespeople, plumbers, electricians, people like that. For a couple of years into TradesCloud's life, smartphones were starting to become ubiquitous, and our customers wanted to be able to use these phones to provide better service to their customers, to give techs in the field access to job details, the ability to report their on-job status, and to provide supporting evidence like photographs of damage, things like that. And so, in the early 2010s, I found myself working out how to deliver a mobile app for Android and iOS while also maintaining the core website for the company. We tried using a mobile-optimized web page, but the web just wasn't up to the task. I ended up using PhoneGap, which is a cross-platform JavaScript mobile app framework. And aside from the many quirks of PhoneGap as a tool, the fact that it was a JavaScript framework meant that there was a bunch of Python logic that I then had to duplicate in JavaScript. Which got me thinking, why can't I develop a mobile app in Python? Around the same time, in my copious free time, I was playing around with another idea. I started using Python in the late 90s, but I started programming in the mid 80s. And by the late 80s, I was using the Borland suite of tools. Turbo C was a code editor, compiler, and interactive debugger that was console-based, but incredibly powerful and easy to use. But here I was in the 20-teens with a high-definition color display on my laptop using text mode PDB as a debugger. Why couldn't I have a nice user interface to step through my code? And okay, there are and were IDEs for Python, but why did I need to swallow the footprint of an entire IDE just so I could debug code? Why couldn't I have a GUI app that was just a debugger, just a test runner, just a coverage tool? A tool that did one thing and did one thing well, a graphical user interface, with a graphical user interface. My first attempt at tackling this problem was a test runner called Cricket, a test suite, just like test cricket, takes a long time to complete. So Cricket lets you visualize your test suite while it's running. You get a navigable hierarchy of tests on the left. You select a specific test, you get all the details of that test, the name, description, how long it took to run, the success, failure status of the test, any errors or output generated by the test, all while the suite is actually still running. So if you get a failure on test 3 out of 3,000, you can start investigating and fixing it right away. One of the goals that I set for Cricket was an optimized end user experience. A user should be able to pip install Cricket and just use it on any platform. That immediately eliminated most of the popular cross-platform GUI frameworks of the time, like Qt and WX Windows, because at the time, both of those required an external library install and then a really weird convoluted process for getting the Python bindings. So I built Cricket with the GUI toolkit that is baked into Python, tkinter. I regretted that choice very quickly. tkinter has enough functionality to visualize a test suite, but I very, very quickly hit up against its limits. For example, there is no web view widget for tkinter, and adding one would not be a simple task. I tried. So I was looking at my options, and as part of that process, I was looking at the source code for Pygame, and noticed that the code for wrapping native platform APIs for game purposes were actually pretty straightforward, which led me to think the most dangerous words in the programmer's lexicon. How hard could it be? The basic widgets are basically the same on every platform. I just need to wrap them in Python, right? And Pygame can do that with pure Python, so I could write a pure Python native GUI toolkit. But why would anyone care about yet another GUI toolkit? And then I cast my mind back to my day job. I need to be able to build a mobile app that uses Python logic. So one of the ways I could make people care about a new GUI framework is if I make it really cross-platform, make it support iOS and Android. I've just got to get Python working on iOS and Android first and then bridge to the native libraries. How hard could it be? Maybe I could even get it to work client-side in the browser. After all, Gary Bernhardt's just given this talk at PyCon US about ASM.js and getting any code to run in a browser, and Ryan Kelly was giving presentations about PyPy.js, about showing Python running in the browser. Maybe I could even get this widget toolkit to work for client-side web app development instead of using JavaScript. And so began the BeeWare project. BeeWare is not one thing, it's an umbrella project. It incorporates a bunch of projects, some that compile Python for mobile and for the web, libraries for bridging from native platform APIs to Python, tools for deploying Python code as apps that others can then use, a cross-platform native GUI framework, and last but not least, a bunch of apps that use that GUI toolkit. I'm actually using one of them right now. Podium is a pure Python cross-platform slide presentation tool. I have been working on BeeWare for just over 10 years at this point. It is, as you can imagine, a big project. I have made slow but steady progress for the first 7 years, and I presented about it at conferences. I organized sprints to try and lure people into contribution. I got a handful of corporate and individual sponsors that helped cover some of my travel expenses. And I got a grant from the PSF at one point to do a big chunk of work on the Android backend. Things really changed about 2.5 years ago. About April of 2022, I was hired by Anaconda, the Python software one, not the camping store. In previous jobs, I had been hired because of my open source credentials, but my open source work was a sideline thing. It was tolerated on work time, but not actively encouraged. Anaconda is different. I was hired by the open source team with the specific mandate to work on open source projects, my open source projects, and they hired another person, Malcolm Smith, based in London, to work with me. For the last 2.5 years, I have been paid full-time to work on BeeWare, to do the development necessary to make iOS and Android viable platforms for Python development, and to develop the rest of the BeeWare suite in support of that goal. Why is Anaconda funding this effort? Well, in part because Anaconda is a company that has been built on the foundation of the Python open source ecosystem, and they see it as their responsibility to give back to the community that has contributed so much to the success of Anaconda as a company. It's not entirely altruistic, though. Anaconda makes money by selling subscription services to large corporations, companies where services like license compliance and security auditing and software bill of materials and that sort of thing are an essential part of doing business. The more people that use Python, the more people that will have a need for Anaconda services. So if iOS, Android, and the web become platforms where people are using Python, then Anaconda's addressable market size just got bigger. Having 2 people work on BeeWare full-time, as you might imagine, speeds up progress dramatically. And as a result, in October of last year, we reached an important milestone. For several years, Malcolm and I have maintained various patches for Python to let it run on iOS and Android. Late last year, we wrote a pair of PEPs, PEP 730 proposing iOS as a Tier 3 supported platform in CPython, and PEP 738 proposing Android for the same. Tier 3 support means that CPython officially recognizes the existence of the platform. There is a build bot that verifies every commit on the platform, and there's at least one core team member committed to supporting that platform. Over the course of this year, Malcolm and I have landed a series of patches in main, or in the mainline, and as a result of that work, Python 3.13 will officially support iOS and Android without the need for any additional patches. In 3.13, it will be source only, so there won't be a download of a precompiled iOS binary on python.org or an official Python app in the App Store. But I can say, hand on heart, that Python 3.13 supports iOS and Android. And as a result of that work, in the last 20 years of work in the Python community generally, in May of this year, I was invited to join the CPython core team primarily to ensure that iOS stays supported. So, the most proximal answer to the question, who am I and why am I here, is that I keep making weird life choices, and as a result, I've accumulated lots of experience using Python, developing Python for others to use, both in the sense of developing Python libraries that people use, and in the sense of literally developing what Python is. Which brings me to my talk, entitled Whither Python. If you're not familiar with the word, it is archaic. It is an adverb meaning to what place, or to what situation, position, degree, or end. Whither will they go means where will they go. It can also be used as a conjunction with essentially the same meaning. And so, whither Python? Where is Python going? What does the future of Python hold? Well, to my mind, one of the answers to this comes in the form of mishearing the question itself. When I first announced the title of this talk to one of my friends, I'm not sure if I mumbled or they misheard me, but their response was, whither Python? Which, frankly, wouldn't be the worst description of the last 20 years of my life. You want to build a web server with a Python. You want to build a mobile app with a Python. You want to build a client-side web app with a Python. And yeah, you can. For those who haven't seen it before or haven't seen it in a while, here is the speedrun version of the BeeWare suite. Step 1, create a virtual environment. Install Briefcase. BeeWare's app packaging tool, pip install Briefcase. Step 2, bootstrap a new project. You could do this by writing a bunch of code and configuration files by hand, but if you are starting from scratch, Briefcase includes a wizard to start a new project. Run Briefcase new, you'll be presented with a list of questions with explanatory text. You get asked for a project name, your name, email, license details, and your preferred GUI framework. In our case, we're going to use Toga, BeeWare's GUI framework. This will spit out a bunch of code and configuration files for a fully functioning project. Step 3, run your app in developer mode. You run Briefcase dev. Briefcase will use your project configuration file to work out how to run your project in your local virtual environment. The first time you do this, it'll install all your declared dependencies and it will start your app. At which point, you'll have a working app. It'll be an empty window, but it'll be a working GUI app. You can now iterate, adding code to that app. So, we edit the code of the app, we want a label and a text input, some other code. Don't worry too much about the details here. Suffice to say, there is some Python code that uses the Toga API to put widgets on the screen. Save those changes, rerun Briefcase dev, you'll get an updated version of your app with some native widgets there for you to play around with. Awesome, we've got ourselves a fast development loop for our app. Eventually, the time will come where we're ready to package our app for distribution. Step 5, we run Briefcase create. This populates the code necessary to create a redistributable artifact of your project. In my case, I'm running on a Mac, so it'll be a .app bundle. It downloads a copy of Python that can be embedded into that bundle. It downloads a stub binary that can be used to start the application. It installs things like application icons and other resources, and it also installs a copy of all of your dependencies into this standalone app environment. Step 6, build your app, Briefcase build. Exactly what happens here depends on the platform. On macOS, all that's required is code signing. On other platforms, there may be some compilations and metadata that needs to be updated. Step 7, start your app with Briefcase run. and you'll see a fully functioning app on your desktop. An icon in the taskbar, app name in the menu bar, whatever is platform appropriate. I have run this app on macOS, so I get a macOS app. But if I'd run it on Windows, I would have gotten a Windows app. If I'd run it on Linux, I would have gotten a GTK app. Step 8. We've now got our app, so we can package it for distribution. Run briefcase package on macOS. That will generate a DMG or a PKG installer. On Windows, you'll get an MSI installer. On Linux, you'll get a native system package, RPM, Deb, Arches, Z package. Or alternatively, you can tell it you want to generate a Flatpak. Okay, but BeeWare is a cross-platform toolkit, so I can also run the same code on iOS or Android. All I need to do is add iOS or Android to the briefcase commands that I've run before. Briefcase create iOS, briefcase build iOS, briefcase run iOS. And with no code changes, you'll get the same app running on the Android emulator or the iOS simulator. It will also deploy directly to an Android phone if it's plugged into your laptop. Briefcase will manage compiling the app for those platforms, creating or selecting the emulator to use, and deploying to that emulator. Where possible, it will even manage the process of downloading the tools you need, like the Android SDK. And where it can't, it will tell you where you need to go to get the things you need to download to be able to run the app. And cross-platform doesn't just mean mobile, so if you want to deploy for the web, add web to all of the commands, and that's what you'll get. Again, from the same input code, you'll get a single-page web app. When you click on the button in the GUI, the button is attached to a handler that will run some Python code. That business logic, that handler code is running in the browser. BeeWare is using the PyScript toolchain to get a full Python interpreter in the browser. It's a single-page web app written entirely in Python. No HTML, no CSS, no server-side component other than serving the page initially, just Python. Now, GUI frameworks and web browsers are great, but sometimes you just want a simple text interface, and Toga can do that too. This is a text mode GUI using the same source code as all the previous examples with no modifications. It's using textual under the hood as the GUI framework. Okay, so some notes and caveats. The web and textual backend are experimental at this point. They're nowhere near as capable as their desktop and mobile analogs, but the base capabilities are there. We are literally now at the point where what we need to do is just crank the handle to make the code come out. The technically difficult part, getting this thing to work on a web browser, is all sorted. But what is produced on all those platforms is a 100% native app. They're not platform lookalike themes. They are native widgets with a native look and feel and all of the native platform capabilities like accessibility shortcuts baked in. And all the other capabilities of the device are also accessible. We've got cross-platform APIs for cameras and geolocation and for managing permissions associated with that. But in short, if your phone can do it, you can drive that functionality from Python if you need to. I have been giving examples of GUI apps, but you can also use Briefcase to package straight-up command line apps if you want. When you run the PKG installer or run the MSI installer, the binaries will be on the path ready for users to invoke. And to be completely clear, those installers are completely standalone. If I take that DMG installer and give it to anyone with a Mac, x86 or ARM, the app will run. I don't need to tell them how to install Python, how to create a virtual environment, or how to pip install something. The app will just work. It is an app exactly the same as any other app on your launch bar. The same goes for the Windows installer, the Linux installer. On iOS and Android apps, they could be submitted to the App Store or the Play Store as you need it. So, that's the whirlwind tour of what BeeWare can do. If you want to try it out for yourself, there's a full tutorial at docs.beeware.org. That tutorial will step you through basically everything that I've just done with a whole lot more detail and demonstrating some other nifty features along the way. But that's just BeeWare's contribution. There are lots of other weird and wonderful places you can do things with a Python. I've already mentioned one that BeeWare uses, PyScript. PyScript is a set of usability affordances wrapped around Pyodide, which is a project that compiles CPython for the browser using WebAssembly. No discussion of unorthodox deployments of Python would be complete without mentioning MicroPython. Python on embedded devices isn't new. It's been around for 10 years or more at this point, but it continues to develop and find new applications. One of those interesting applications is the web. One of the criticisms of Pyodide is that it is a very big initial payload to want to deliver in a web browser because it's the entire CPython interpreter delivered to your browser. But MicroPython is very small. And because it's written in C, it can also be compiled for the web. Recent versions of PyScript let you swap out the Pyodide interpreter for the MicroPython one. If you don't need the entire Python language, you just need the ability to run some Python language in the browser. We're also starting to see Python be officially adopted as a customization option in much larger applications and projects. Blender and FreeCAD have used Python for a while, but as of last year, you can add Excel to that list. You can now embed Python code directly in an Excel data cell. Pass data from the cell to your Python program, perform analysis with pandas, scikit-learn, spit out a matplotlib chart, and then have those results visualized back in your Excel sheet. Now, full disclosure, that support is provided by Microsoft officially. It is backed by Anaconda's packaging toolchain, so I do have a very slightly vested interest there. But even with that knowledge, that's cool stuff. The modern world is held together by a series of load-bearing Excel spreadsheets, and we're now in a position to use Python in those tools. So yeah, there's a lot of places you can do things with a Python, where even 5 years ago, it really wasn't possible. And so looking to whither Python is headed, it's reasonable to assume that that work is going to continue. What platforms are next? I don't know. For what it's worth, I have ported Python to Apple's tvOS. I haven't really done with it beyond a proof of concept app. I've got the patches to compile it for watchOS, but I don't have an Apple Watch, so I haven't really tried them. I haven't looked at visionOS at all, but if someone wants to buy me a VR headset, just saying. In terms of BeeWare's work, while we have got Python running on mobile, that's just the core of CPython. There's also the rest of the ecosystem, Pillows and NumPys and SciPys of the world. It is possible to compile these libraries for iOS and Android, and we have done that for certain select packages manually, but it's not trivial, and you can't currently upload iOS or Android binaries to PyPI. That is an area where Malcolm and I are actively working right now. You can probably expect to see announcements about that in the coming months. There are also some very early discussions going on about providing official binaries for mobile platforms, so official downloads for Python on Android, Python on iOS, probably in the form of a developer toolkit of some kind, maybe even an official binary, official Python app in the App Store, maybe. Now, supporting new platforms is great, but we should probably also address the criticisms of Python on existing platforms as well. And the biggest recurring criticism of Python is always speed. Good news is, this is an area of active development. And whenever one of these discussions pops up, the finger usually gets pointed at one thing, the GIL, the Global Interpreter Lock. Python is slow because of the GIL. Okay, the GIL is ultimately a mechanism for thread safety. The GIL only affects multi-threaded, CPU-bound operations. And I'm sorry to break this to you, but most problems in this world are not multi-threaded, CPU-bound operations. I am not saying that the GIL is not an issue. It absolutely is. There are multi-threaded CPU-bound problems out there. But the discussion about speed is a lot more nuanced than Python slow because GIL. Removing the GIL is a bit of a monkey paw situation. I want a Python without a GIL, you say. Wish granted. Now you need to either care what a mutex is and care about thread deadlocks, or you need to pay a performance penalty while Python carries around all the accounting overhead of making sure you don't have to care about mutexes. Over the years, there have been multiple attempts to remove the GIL. Unladen Swallow, the Gilectomy, and others. The current effort is PEP 703, known as free threading. PEP 703 free threading takes the accounting overhead approach. As a user or developer, you will not have to care about mutexes. Python will continue to do the right thing by tracking potential conflicts at the per variable level. This comes at a performance cost. Python's performance is, for the most part, a function of the trade-offs that have been made. And many of those trade-offs have directly served the usability of Python as a language. The GIL is one of those trade-offs. It makes multi-threaded code 100% reliable for non-expert programmers at the price of a performance limit for highly parallelized CPU-intensive code. Removing the GIL would also be a trade-off. There is an open expectation that the addition of free threading will, in the best possible case, have the side effect of making single-threaded Python code 5 to 10% slower. It is a trade-off. Is it an acceptable trade-off? Time will tell. The work around free threading is underway and will probably be underway for another couple of years. It is worth noting that in their acceptance of PEP 703, the Steering Council has made it very clear that reverting free threading is absolutely still on the cards. Free threading is available in 3.13 as an experimental option so that the broader Python ecosystem can evaluate the impact of the changes. But in the long term, in 5 years or so, free threading will either become the default because it is stable and reliable and doesn't have a big enough impact to be concerned, or it will be removed. There is no future where there are two versions of Python. But free threading and GIL removal is not the only speed improvement effort that is currently underway. To my mind, the unsung hero at the moment is the Faster CPython project. This is a long-term project. It's been driven by Mark Shannon and the CPython performance team in Microsoft, amongst others who are working on it. Python 3.11 saw a 25% speed up on most workloads over Python 3.10. 3.12 saw another 5 to 10%. 3.13 is looking like adding maybe another 5%. Add those up, Python today is 30 to 40% faster than it was 3 years ago with no changes to code at all. Those improvements are mostly due to PEP 659, the specializing adapter interpreter changes, and the consequences that have flowed on from that. And interestingly, these recent speed improvements are at least part of the reason that a 5 to 10% performance drop from free threading are being considered acceptable at all. So, where are the faster CPython people looking right now? Well, one of the biggest efforts is just-in-time compilation, or JIT compilation. What is just-in-time compilation? Well, the core idea is that if your interpreter can gather information about how it is running at runtime, it can, at runtime, replace sequences of operations with highly optimized machine language versions of the same sequences. In an ahead-of-time compiled language, like Rust or C, those optimizations are performed by the compiler based upon having full knowledge of the data types at time of compilation. Dynamic languages like Python or Java or JavaScript don't have that full prior knowledge, so they need to resort to runtime techniques to speed up once they know what data types they're actually dealing with. JITting is not a new idea. It's not even a new idea in the Python ecosystem. But in 2021, a researcher working on the Lua language developed a technique called copy and patch. The copy and patch technique is conceptually reasonably simple and relatively easy to implement. We're talking on the order of hundreds of lines of human-managed code. But it seems to yield almost as much performance as a handcrafted, incredibly complex and customized JITting technique, between 15 and 50% increases in speed over the baseline interpreter. If you want to know more, copy and patch technique is described in detail in this blog post, which is written by the researcher who came up with the technique. If you understand how C is compiled, it's a fairly approachable introduction to JITting as a general concept and as copy and patch as a specific technique. Or if you want a more Python-focused introduction, there were 2 presentations at PyCon US this year that discussed the JIT, one by Brant Buchner, one by Ken Jin and Jules Poon, both well worth watching, very approachable talks. As of Python 3.13, the mechanisms for the copy and patch JIT are in place, but there hasn't been a whole lot of effort put into what is actually being copied and patched. Time will tell if Python is able to see the same sort of speed gains that the Lua interpreter has seen sort of in experimental loads. Outside of speed, what other changes are on the horizon? Well, the 3.13 cycle has seen the emergence of 2 working groups inside the core team, one focusing on the stability and long-term evolution of the C API, and one with the mandate to add as an editorial oversight board for documentation in the project. Those are not specific things that are going to change yet, but they are indications of areas where the core team is aware there is an issue and they're looking to improve in the long term. But okay, so longer term, what is on the horizon? Well, the future is notoriously difficult to predict, and the future of open source doubly so. One of the great challenges of open source is that it's really hard to make concrete long-term plans. As the maintainer of BeeWare, I can write roadmaps and strategic plans, but ultimately the work that gets done depends on who shows up. I am in the very lucky situation that I can directly influence the contribution of 2 engineers. But if Joan Q. Hacker turns up tomorrow and submits a pull request for a feature that wasn't on my roadmap, then either I reject the contribution and constrain the rate of progress, or that's where the road goes, I guess. Ultimately, where Python goes will depend on who shows up to do the work. Right now, that's me and Malcolm doing BeeWare stuff. It's Meta doing free threading stuff. It's Microsoft doing faster CPython stuff. It's all the other contributors working on the various PEPs that are under discussion. Who shows up depends on who is using Python and what they're using it for. Python is regularly at the top or near the top of most lists of popular programming languages. But why is it popular? Who is it popular with? And to lean on another possible mishearing of my talk title, what could cause that to change? What might cause Python to wither, to shrivel up, and die? One way to predict the future is to look to the past and how Python as a language and as a community has changed. I put it to you that there have been 3 eras of Python which almost perfectly line up with the 3 major versions. Python was first announced February 20th, 1991. The first 10 years of the project are what you'd expect from any newly announced language. It was trying to work out what it was as a language. It was originally conceived as a teaching language and as a language to make programming accessible to the masses, which strongly influenced many of the design decisions about the basic language, like significant white space and the lack of braces in the language syntax. There were other uses and users of Python in this era. I first used Python in this era where it was being used by Red Hat to drive their installer configuration, amongst other things. But it was very much a niche language. This initial era lasted until the release of Python 2 in October of 2000. The transition from Python 1 to Python 2 wasn't that big of a deal from a pure language standpoint. There weren't any huge language changes. There were changes, but they were all opt-in. The biggest changes were logistical and legal. There was a major license change, and the development of the language moved to BeOpen, who were developing Zope, a web-based content management system built in Python. This was the height of the .com era, and so every language was trying to work out its web story. Somewhat famously, at PyCon 2005, Michel Levesque gave a talk entitled PyWebOff, Mapping the Python Web Application Frameworks, in which he highlighted dozens of web frameworks and tried to answer the question, which one should I choose? This, of course, led to the development of two new web frameworks, Django and TurboGears. Eventually, the web became overwhelmingly the reason that you used Python. As an indicator of this, if you take a look at the top 13 sponsors, in the top 2 sponsor tiers for PyCon US 2014, they were all web or web adjacent. There were 4 SaaS companies, 4 large corporations largely defined by their web presence, 3 web hosting companies, a web development consultancy, and a web-based recruiting company. They were absolutely other users and users of Python 2, but a lot of Python's usage was driven by how easy it was to stand up a database-backed Web 2.0 website. And a lot of that growth was from people without a deep programming background. Django Girls is one manifestation of that, but it's not the only one. A lot of people got into Python because it was an easy way to get something going. Then something changed. There's an argument to be made that Python 3 was almost an extinction-level event. It wasn't, and Python has emerged stronger than ever, but I'd argue that that is almost as much good fortune as good planning. The transition from Python 2 to Python 3 wasn't directly backwards compatible. You needed to wrap all your print calls in parentheses. There were subtle differences and exceptions. Strings are all now Unicode. And so Python users needed to work out how they were going to deal with a complex 2 to 3 transition project. And at the same time, the web was undergoing a transition from Web 2.0, server-heavy websites with some JavaScript front-end, to single-page web apps that were predominantly client-side, with a little bit of server-side serving an API. And so, web developers were faced with either a complex 2 to 3 transition, or a complex transition to a JavaScript-based web framework, which will let them share logic between client and server, and it's definitely where the momentum seems to be, and a lot of them chose the latter. We are extremely lucky as an ecosystem that at the same time Python 3 was trying to find a foothold, data science was experiencing major growth as a discipline. And the Python data science ecosystem was ready for that growth. As a result, the vast majority of these newly minted data scientists started their Python journey on Python 3. If it wasn't for that opportune growth, Python today could be a very different and much less vibrant ecosystem. And so that's where we are today, in the Python 3 data science era. Again, looking at PyCon US 2024 sponsors as a proxy. Of the top 15 sponsors, only 2 could be considered tangentially web service providers. All of the others are either corporations whose interests are now AI or data analysis, or companies that sell hardware to people doing AI or data analysis. And again, a lot of this audience aren't programmers first. They're data scientists, they're analysts, they're quants. They're not coming at this with a 3-year degree in operating system theory. They're coming at this as math majors with a job to do. And the fact that Python comes with an ecosystem of tools that lets you build a website and read Excel files and build interactive plots, those are the things that make Python useful. So, that's 33 years of Python history we can use as a basis to predict the future. But there's another language ecosystem whose history I think is worth looking at. It's another example of a language that once had a very substantial audience, but lost it completely. A language that was faced with a large language transition, but unlike Python, didn't survive. I'm talking about BASIC. The beginner's all-purpose symbolic instruction code. I mentioned earlier that by the late 80s, I was programming in C using the Boolean suite, but BASIC was my first programming language. It's the first programming language of most people of my vintage because it was the language that was baked into all of the computers of the 8-bit era. The Apple II, the ZX Spectrum, the BBC Micro. For me, it was the Commodore 64. You represent! You turned on your C64 and in seconds, you were at a programmable BASIC prompt. BASIC was the interface to your computer. This made it a great educational resource because you didn't need to explain to people how to get started. It was immediately accessible by default. And as a result, you ended up with resources like these: computer space games and computer battle games. Books that gave you all the source code for games that you could type in and see a game that you had written. Now, okay, the games were, for the most part, pretty lame. Text mode, guess the random number type stuff. The games were entirely sold to me by the quality of the box art, not the gameplay. But you're missing the point. I wrote a game. Eventually, my Commodore 64 gave way to an IBM PC-AT running Microsoft DOS, and BASIC came along for the ride. BASIC is part of the origin story of Microsoft. The very first piece of software that Microsoft produced was a BASIC interpreter, literally written by Bill Gates. Now, at this point, I was getting more serious about programming, so I was moving on to C and C++, but BASIC didn't go away. Instead, it went from strength to strength, becoming the configuration and customization language for every Windows application. It even became a fully fledged app development language in itself, Visual Basic. If you had an in-house custom GUI application in the mid to late 90s, chances are it was written in Visual Basic. If you wanted to extend Excel to do a customized calculation, your formula was written in Visual Basic. But in the mid to late 90s, two things changed in the computing world at about the same time. The first was the internet. Bill Gates famously failed to predict the impact the internet would have on his company. The first edition of Gates's manifesto, The Road Ahead, published in 1995, only makes a passing reference to the internet. Within months of publication, Gates had directed Microsoft to be an internet-focused company. And in less than a year, a completely revised and up-to-date second edition of The Road Ahead was published, with extended details about the internet. And so, Microsoft was playing catch-up. What did this mean for Visual Basic? Well, Microsoft tried to push VBScript, Visual Basic, in the browser, but it only ever worked in Internet Explorer, which meant it couldn't be universally relied on. And so, Visual Basic couldn't be used on the major platform of the day. Okay, but you could still use Visual Basic on the server, right? Well, yeah, active server pages could be written in Visual Basic, but then VB got hamstrung by another change. As the web emerged as a platform, so too did Java, the revolutionary new write-once-run-anywhere language that was just perfect for running web servers. And with applets, it could run in the browser too. Microsoft needed a strategic response to this, and so they came up with a new language called C#, which ran on a new runtime called .NET, because Microsoft was an internet company now. All of the languages that Microsoft supported were ported to the .NET runtime, and all of the .NET languages were compatible, so you could call a C# object from your Visual Basic, as long as you were using Visual Basic.NET. But Visual Basic.NET wasn't backwards compatible with Visual Basic 6. You had an existing VB6 codebase. It would need some major upgrades to work on .NET, like explicitly declaring arguments and exceptions and wrapping function calls in brackets. Sound familiar? And so, being faced with either being forced to upgrade their Visual Basic 6 code and being presented with the option of maybe converting that in-house app to a web app, developers were faced with the choice of retooling their entire VB6 into VB.NET or picking a new Java-based technology stack that was clearly web first and where all the momentum was. Visual Basic lost its market share. In the mid-90s, Visual Basic was load-bearing critical infrastructure. Within 5 years, it was the legacy language that unfortunately you just had to deal with. Visual Basic.NET still exists, but BASIC isn't anyone's first programming language anymore. That's two histories. 33 years of Python, 40 years of BASIC. What can we learn from these histories? Well, the one obvious lesson: big language changes kill ecosystems. The good news here is the Python core team has learned its lesson here. The phrase, "there will not be a Python 4", has been uttered at a couple of Python core team summits that I've been present at. That's not to say that Python will stop evolving, but it is saying that if there is ever a version of Python that has a 4 at the start of its version number, it won't be a backwards incompatible ecosystem split like Python 3 was. So much so that PEP 2026 exists, suggesting the adoption of calendar-based versioning for Python. So the X in 3.x will become the year number. The discussion around this PEP is ongoing, but the fact that it's not being dismissed out of hand is indicative about the way the core team views the future of the language as something that can and must evolve, but isn't going to go through another generational split. And you can see this in the discussions around free threading. A major focus of these discussions is whether we are able to introduce the changes in a way that doesn't cause a schism in the ecosystem. How do we ensure this transition doesn't cause a split in the ecosystem? The other major lesson, new platforms are critical to future success. What people expect of computers has changed multiple times in my lifetime. When I was born, computers were mainframes. Then they were 8-bit home appliances. Then they were 16-bit text mode desktops running DOS. Then they were 32-bit graphical desktops running Windows. Then they were thin clients running a web browser. Then they became phones and embedded devices. As new platforms emerge, it's important that languages evolve to be on those platforms. And there's value in doing that. When you add support for a new platform, all the capabilities of the language ecosystem from the old platform become possible on the new platform. That is a powerful force multiplier and a powerful advantage for an existing language. Each of these generational shifts is also an opportunity for a new language to emerge and an opportunity for existing languages to pivot to a new audience. If a language can't be used where computing is being done, people won't learn the language. The important corollary of this is that computers are, ultimately, tools. And as people who tinker with technology, sometimes professionally, sometimes just for fun, it behooves us to remember that most people don't use technology because they enjoy tinkering. They use technology because it lets them get stuff done. My first job out of university was a company that did a lot of defense consulting. We developed all sorts of computer-aided wonders. At one point, I was extolling the virtues of a new web-based system to someone high up in Australian Army. And he turned to me and said, "You know what the Army would consider the perfect technological advancement? A self-sharpening grease pencil." There have been all sorts of institutional reasons why I and the company I worked for had been contracted to build the fancy computer things that we were building. What the customer actually wanted was a tool that could be held upside down in a muddy puddle and would just work. The technologies that people use are the ones that let people get stuff done. But it's even more profound than that. The most important part of getting stuff done is getting started in the first place. I can draw a direct line from the quality of Django's documentation, and in particular the onboarding experience of its tutorial, to the fact that I became a member of the Django core team. And in the early years, Django had a pair of BDFLs, Adrian Holovardi and Jacob Kaplan-Moss. Adrian and Jacob both come from a liberal arts background. Adrian is a journalism major, Jacob is an American literature major. And so they sweated the details of Django's documentation as a piece of writing. As a result, it was extraordinarily effective at onboarding people with no history in web programming into a whole new way of thinking about things. And to be clear, this doesn't mean dumbing things down. Making your API and documentation accessible to newcomers doesn't mean hobbling functionality. Django can be used to run a Django Girls event. It is also used to run Instagram. What it does mean is considering the experience of your users, and especially your new users. It means considering your pedagogy, the way you structure ideas and concepts, the order in which you present them, so that they can be learned. How are ideas presented to a user as they go from knowing nothing to being able to wield your tool as an expert? This is, in part, a documentation issue, but your APIs and architecture are part of that pedagogical process. I remind you, I have a PhD in computer science, and I couldn't work out how to use PHP given the state of its documentation and tutorial in 2005. PHP is clearly a powerful tool, but I couldn't work out how to use it, so I went elsewhere. If you do this enough times to enough new users, you won't have users. By all means, focusing on raising the height of the ceiling you can reach with your tool. Just make sure that as you do, you don't inadvertently raise the floor as well. Engineering a tool or an API so that it's flexible is a good thing. It's great to be able to stretch the bounds of what is possible with a library or a framework or whatever, to increase the range of possible applications. Instagram isn't going to use your framework if it can't scale to the levels that they require. But that can't be at the cost of preventing people from starting in the first place. In the Python context, what is potentially concerning here is the large-scale engineering resources that are being made available to develop Python as a language are being made available by organizations who need a higher ceiling but don't have any particular skin in the game when it comes to the floor. Free threading has been developed primarily because the operations division of Meta wants to reduce their server hardware costs. That's great for Meta, but the vast majority of users don't have a guild problem. And if Python is harder to use just so Meta can save some money on servers, who wins? Typing is another example. In a large engineering organization like Google or Dropbox, formal type checking is a way to improve engineering rigor because you're dealing with hundreds, thousands of engineers who don't have close interpersonal ties, and automated validation systems are an important part of guaranteeing quality. But if you're an engineering team of 5, the proposition isn't quite as clear. And it probably doesn't exist at all if you're just starting out. Now, to be clear, I think the Steering Council is doing a good job here. They are considering the needs of new users as part of this discussion. Again, this is part of why free threading has been introduced with the escape clause that might walk it back, why the messaging around typing has been that it won't ever be a runtime requirement. But it's not just the Steering Council's responsibility, it's the whole ecosystem. When a new user comes to Python and they're bombarded with discussions about whether they should be using Poetry or PDM or pipenv or Rye, or setup tools or Hatch or Flit, or even how to install Python, we've just made the floor harder to get onto. And there is a practical limit. If there is a practical limit to how low you can drop the floor, then you need to build ramps to get people onto that floor. It may be easier to throw up a ladder or build a quick set of stairs, but a ramp is accessible to more people under more situations, and even if you are able to scale a ladder or climb upstairs, a ramp is usually more pleasant to start with. I'm sure I could work out your library's complex architecture. Why should I have to? If your competitor provides a ramp and all you provide is a ladder, guess which one I'm more likely to use? Just as it is with physical affordances, accessibility ramps make life better for everyone, regardless of their circumstances and whether those circumstances are permanent or temporary. And as proof that building ramps works, you only need to look at the biggest sources of Python growth, or biggest sources of growth in the Python ecosystem in the last 10 years. First is data science. Look, the ramp that gets people into data science is Jupyter Notebooks. Jupyter Notebooks let people run a simple command, get a working interactive data analysis and visualization environment. It's delivered through the web, but the end user doesn't really care about that. The web is a means to an end. Are there limits? Yes. Is it perfect? No. Do you know what it can do? You can start it, and you get started with the data analysis. And from there, you can evolve into a broader ecosystem of data analysis pipelines and much more. The Internet of Things. Get a MicroPython device from CircuitPython or Adafruit, plug it in via USB, drag a file onto the device. You've got some blinky lights that you programmed. In some cases, the user experience is delivered through the web, but the end user doesn't need to care about that. The web is a means to an end. Are there limits to what it can do? Absolutely. Is it perfect? No. But you know what you can do? Start it and get started with hardware programming. And you have a whole new generation of 10-year-olds running around with the 2024 equivalent of guess the number computer space games. Python's ability to grow in the future depends on our ability to make good ramps for new users. And I think there are still opportunities for Python to develop substantial new user bases. In the mid-90s, Visual Basic 6 was huge. You could use a graphical designer to pull together some components, connect some data sources, and you had a customized user interface you could deploy across your organization. VB6 was essentially supplanted by the web, but the development experience of Visual Basic has never been replicated on the web that I've seen. Over the last 25 years, I have seen generation after generation of web technologies fail to achieve the simple heights of what was the baseline user experience in 1995. The need hasn't changed. As a user, I want to put a user interface over some data capture or workflow control. I want to interact with some data sources, and I want to be able to serve that user interface to the device that the user has. What has changed is the user's expectation about where that user interface will be experienced. In the 90s, it was a native app on a desktop machine. These days, it could be a desktop app, but it could equally be a web browser, a native app on a desktop machine, an Android phone, an iPad. None of that matters to what the user wants the app to do. They're just different platforms surfacing the same user interface. I genuinely believe there is an opportunity here, and Python is in the perfect position to exploit this opportunity. Python can run on the desktop. As of Python 3.12, it can run in the browser. As of 3.13, it can run on iOS and Android. It is a well-known, well-liked, accessible language that is accessible to people who aren't experienced programmers, and it has a rich ecosystem of libraries and extensions that can be used to make the language do more. Giving new users a reason to use your project, making it easy for them to do so, is important, but it's also important that at least some of those users turn into developers, and their ramp needs to be accessible as well. If they don't, then the ability of the project to adapt over time will be limited. This is especially significant for programming languages. Being able to use Python isn't necessarily sufficient to be able to fully contribute to Python, because a good chunk of Python isn't written in Python. It's written in C. And knowledge of C and auto tools and that whole ecosystem is increasingly a niche skill the vast majority of Python users don't have. In Python, the situation is actually, I think, being made mildly worse by another trend, the emergence of Rust. Don't get me wrong, Rust is, by all accounts, a great language. It's probably a great fit for many of the users it's being put to, but it is yet another language that isn't Python, with its own learning curve, and so the bar to contributing to Python just got a little bit higher. We see this same phenomena with BeeWare. The set of people who know iOS and Android internals and Python internals is me and Malcolm, maybe a handful of other people. NumPy and SciPy see it. Part of that tool chain requires Fortran experience. These are learnable, knowable skills, but when you increase the set of prerequisites for contributing and add increasingly niche requirements, that's a barrier to entry, especially when the development of the ecosystem is dependent upon volunteers. And in the long term, that's a risk because it limits who is able to contribute. I don't know the answer to this one. One I'm particularly motivated to address because it literally constrains BeeWare's rate of progress. Ideas on a postcard if you know how to solve it. But regardless of whether someone is a user or a developer, they are not going to remain in your community if the community itself is toxic. Your community has to be a place where people actually want to spend time, especially if it's driven by volunteers. Unfortunately, there are people in this world who just don't know how to play respectfully with others. Some of them are even quite talented from a technical perspective. But when they don't recognize that their behavior is causing harm to others, and they resist any form of remediation, they need to be ejected from the community for the good of the community, because they are making the space somewhere that newcomers, and even some old-timers, don't want to be. In any community of significant size, no single person is so critical that they shouldn't be held to reasonable standards of conduct. This is something that CPython has faced over time, most recently with the occasionally vile discussions about changes to the PSF bylaws. Some of the discussions around those changes made me furious beyond words for a variety of reasons, and I have nothing but respect for the moderators who waded through that torrent of filth for as long as they did. Thankfully, the community as a whole gave a resounding answer to the critics at the ballot box. Sadly, I doubt this will be the last time the issue surfaces, but make no mistake, it is an essential part of a healthy community. To quote former Australian Army Lieutenant General David Morrison, the standard you walk past is the standard you accept. And I'm very glad the Python community has made it clear this is something we will not walk past. So, Whither Python? Well, I certainly hope it's not the last option. I think we've got a reasonable basis to say that it won't be, or at least that it's our position to lose. It would be difficult for another language to develop an ecosystem with the breadth and depth of Python's. Not impossible, but difficult. And, as the Python 2.3 and Visual Basic examples have shown, dominant languages can easily lose their dominant position if they don't pay attention to how the world is changing and how changes made by a language can impact its users, how the tool is developed, and how the community itself evolves over time. Speaking for myself, I have been working on BeeWare for over 10 years, specifically because of the strategic gaps and opportunities that I believe exist for Python as a language. I am planning to keep working on Python as a language and Python the ecosystem in service of filling those gaps. We've got big plans for where BeeWare goes next, both in the short term and the long term. I am paid by Anaconda to work on BeeWare. They have paid for me to be here today, so I'd like to thank them for that support. But while Anaconda pays me to work on BeeWare, the project itself has other funding needs, and Anaconda doesn't cover those costs. So if you like what you've seen here, you'd like to support the BeeWare project, you can join the project as a financial member. You can also back me on GitHub sponsors. That income pays for stickers, hosting, and things like that. Or if you want to get involved, we're always looking for new contributors. We have a long list of features we'd like to add. The barrier to entry, although it is high, is not as high as you might think it is. It is approachable. And we have challenge coins for people who contribute, and stickers if you just want to be cool. Come see me afterwards if you want to know more. We've also got a Discord, discussion forums, ticket trackers for all the projects, details on the website, beeware.org. Python is ultimately community-driven. Whither Python goes is up to us. So, go forth, build great things, build weird things, build new and unexpected things, push Python into weird and wonderful new domains, because the future of Python depends on you. As you do, remember that the things that have made Python successful in the first place, because the things you build and the communities you build around them are what will ultimately determine how long Python's success will last. Thank you all very much. Okay, I can take questions if you want, yeah.
Fantastic. Thank you, Russ. We do have... Actually, keep clapping, keep clapping.
Yeah, keep clapping. That was a great talk, wasn't it? Woo!
Russ, do you want to pitch the cube?
Do I pitch? Oh, guy. Woohoo.
We'll let Russ pitch the cube.
This could end badly.
Who has a question for Russ?
All right, let's start down here.
Yay. Hi.
Hello.
I really like the commentary about existential risk and changing major language versions. My first language was Perl, and the Perl 5 to Perl 6
Yes.
adventure. So my question is, what was the Python community able to learn from Rust or from Perl's failures during the 2 to 3 transition?
Okay, I am not as familiar with the Perl 6 transition as I am with BASIC. Like I knew Perl, or I was around when Perl was around, but I never really got into Perl. Again, it's just a language that just never managed to stick for me. My understanding is that the strategic failure there was, we've got this grand idea for what the next version is going to be, and it just took way too long to get there. It's sort of classic second system syndrome. We have a working system, and now we're going to build the second version, which is going to be awesome, and just never gets there. And as that sort of takes all the oxygen out of the air for fixing the version that we actually have that people are using. So yeah, I think that is probably the lesson to take away there, is that, yeah, the appeal of second, and this is a general lesson for software engineering anywhere, building the second system may look attractive. Gradual evolution is a much safer and much easier way of getting there in the long term.
How about you come over here, because you're in front of the speaker.
Don't stand near the speaker.
So, you were able to get involved in the ecosystem early,
Yes.
when it wasn't feature complete, which made it really easy for you. You also had a lot of experience, which is great. I often wonder about kids coming up now who enter into an ecosystem that already is nearing feature complete, and it's much harder for them to get all the experience necessary. What do you think about Python that way in, say, 50 years when everything's kind of been done? Am I pessimistic?
No, I don't. So there are parts that are complete. There are parts that will never be complete. It is always an ongoing project. Python as a language, reasonably stable. Yes, you need to be getting deep in the weeds to find the edge case of the thing that's improving. But 15 years ago, Django was fresh, and there were places to contribute. And my first contribution was making sure many-to-many table joins could go both directions. Relatively easy to get into. Django now, a little bit more difficult to get into. Most of the features, there is still plenty of stuff that could be added, but it's incremental improvement on an established project. BeeWare, however, we still haven't got a switch widget on the web. I can show you how to do that. That's not hard. I just need more arms. You have arms. Come, let me use your arms. There will always be, as ecosystems evolve, as new platforms come out, as new challenges come out, as new applications get found, there are new problems that need to be solved and new domains where you need to use the language, new libraries that need to be built. There are always new opportunities. The old opportunities are the thing that make the new opportunities possible, and it's this evolution over time. You can get in on the new opportunities, you've just got to find the ones that are interesting to you and look like they're going in good places.
Last question. Cool. Again, just be a bit careful, you're in front of the speaker.
Right, so obviously you've wedded your horse to C Python here. I'm a little bit interested because obviously other people have tried to tackle the same space as you, say, Iron Python on Xamarin and things like that, trying to do the basically
And myself
the same
with
things.
Batavia and VOC. So yes, there are many others.
Yeah, so I mean, why did you go that way? Do you see the health in kind of isolating Python off from other technologies rather than sort of sharing the space with other languages and being another language on top of a
So my counter argument to that would be that the reason that C Python has been successful is because it is C. And for better or worse, C is the lingua franca of making computers talk to each other. The reason why BeeWare is Toga is a cross-platform GUI toolkit that can be done in pure Python is because of C types in the foreign function interface. I can call Objective-C code from Python over C types because it's C at the end of the day. When you get to Java as an ecosystem, that's one of my biggest criticisms of Java as an ecosystem. What they sort of abandoned all of the C legacy, which is where all of the computing had been up to that point to say, hey, if only you use this new binary format, everything will be perfect. And by the way, you've also got to use this language, which is the only thing that's accessible to that language. In some regards, JavaScript is kind of the Java promise, but taking it the other way. Here is a language that we're going to guarantee is available everywhere, and the runtime is available everywhere. But you can kind of then you JIT that down to machine language code, and then Scripton proves that you can compile anything to that JITted format. So you're still talking C at the end of the day. IronPython's a little bit more complicated because then you're into the whole .NET ecosystem, and that's basically the same criticism of Java, except that it's only Microsoft. So, well, yeah, only Microsoft. So I agree that interchange with other platforms is important. I think that 70 years of computing history at this point has basically decided that it's the C linking model that is that. It is now up to us to say, okay, C is a tire fire. Let's make other languages that can target that as a binary format and make everything play together nice.